So this worksheet is asking us to first find the vertex and then the domain and range. So as you may recall, a quadratic function, the vertex is going to be the turning point. And so if we look, one side's coming down, it turns, and then it's increasing. And so all you are going to need to do here is write the coordinates. So in this case, our x-coordinate would be -1, 2, 3. The y-coordinate, -1, 2, 3, 4. So this would be -3, -4. It's then asking you, is that a minimum or a maximum? It's the lowest point on the graph, and so therefore it's a minimum. Think the word mini means low. So over here, our vertex, it looks like it's actually in between 2 points. This one might be a little tougher. It's between 1 and 2, so I'd call that 1.5 or 1.5, comma, and then looks like 2 down, so -2. And again, this one's a minimum. Good example of a maximum would be this here. This vertex is going to be the highest point, so that's a max. And the vertex is always going to either be the lowest or the highest point. Now let's talk about domain. Domain, if you don't recall, is the x values. Where are the x values on this graph? So the x-axis is like a number line. You're looking left to right. And all of the points on this graph are between 0 and 3. There are no points greater than 3. There are no points less than 0. So that's all that I'm saying for my domain. So the number on the left is 0. All of the x's are greater than 0. I'm also going to put a line under that because there is a point at 0, so x could also be 0. And then on the right, all of the x values are less than 3 or equal to 3. So that's going to be a very basic domain there, two-sided. Then your range, same idea. This time we're looking at the y values along the y-axis. So all this is a number line turned, right? It looks exactly like your one-dimensional number line, except that y is the second dimension. So we're looking, what is the lowest value and what is the highest value? Okay, so for y, we're going up and down. The lowest would be -2. I'm going to put that on the low side. And then the highest would be a y value of 0. So I'm going to put that on the right side. So we always put the lowest number on the left, the highest number on the right. Okay, so there's your two-sided domain and range. We also have some problems that look one-sided. So in this case, we're looking at the domain left to right. We can set it up just like before. The furthest number on the left, it looks like it has an x value of 1. Okay, all of the x values are to the right. In other words, they're greater than 1. So the big side should be facing the x. This time that point is not filled in, so I'm not going to put a line. This like open circle here, if you recall, that's what it means for x. The x values could be 1.1, 1.01, 1.001, but it can never be actually 1. So we're never going to put that equal sign. All right, so that's the left side. On the right side, this arrow doesn't mean it stops here. This arrow means it keeps going forever and ever and ever. So all of these x values up here are all going to have points associated. So we just don't put a right side. If there's arrows on one side, your domain is going to be one-sided. And then same idea with your range. There's your y-axis. Okay, on the bottom, it's going down forever to -infinity. So this is going to be a one-sided range. On the top, it stops at 4. So we have y and 4. Okay, so now we have to think, are the y values all less than 4 or are they more than 4? Okay, well 3 and 2, these are all less than, so we want the little side facing the y. Now there are two different ways to write this. So this one says 1 is less than x. That's the same thing as saying x is greater than 1. Okay, lastly, this example over here has arrows on two sides. So, all right, we know what a two-sided domain looks like. We know what a one-sided domain looks like. When there are arrows on both sides, what that tells you, all x values have points to them. So if I chose 1 for my x value, there's going to be a point there because this keeps going. So even if we can't see it on the graph, there still is a point there. So your domain is all real numbers. And the way that we might see this written is XER. That's our notation in mathematics, saying x is an element of real numbers. So it could be anything. And we only use this notation when there are arrows on both sides.